Good evening, everybody, and welcome to the webinar. My name is Shamshad Ansari. What we will do today is that we'll try to understand what big data analytics is about, and I'll go through some real-time use cases. So the agenda of the webinar, as you may already be aware of, is that we would like to understand what big data actually means, and we would like to understand that how big data is different from traditional data, and what are the challenges that big data poses when it comes to building the analytics and solutions around them. I'll go a little bit technical when it comes to understanding the approach and different big data technology landscape, and also we will try to understand what machine learning and how machine learning is used in doing analytics. Of course, the time is very short, so we'll not go into the details of any of those. I will start with some real life practical examples, and then we will go into some different use cases that I came across. Of course, there will be very selective use cases. So before we start, let's get some motivation. This is actually a slide that you're seeing about some of the practical examples of big data analytics applications. You see the first one, Etihad Airways. They use big data technology and big data analytics to understand the data and leverage that data in order to predict if there is any problem, or they also predict several items such as the arrival and departure time. One very important use case that they have is that they predict precisely what time or at what point in time their parts will fail, the aircraft parts will fail. And this is very, very important predictor that they have. So let's go a little bit back. So everybody, and pretty much all the industry use some sort of analytics. But getting the real insight from the analytics is very, very important. So Etihad Airways before used to have some sort of predictive analytics, and they were able to actually predict what time or at what point in time the parts will fail. But they were never precise. Either they failed before time or after their time. So in either case, it was very expensive for them. Now they are able to predict very precisely, and that actually has a huge business value. The way they do is that they actually gather the data from pretty much every single parts of their aircraft and analyze terabytes and petabytes of data that each part generate, and then that actually gives them the information and means to predict at what point in time the parts will fail. So that's basically one of the companies, and of course there is a huge use case out there on the internet, and anybody can go and read. It's a really public information. So let's go into the next one. There are, we all and most people actually on earth are using, a lot of people actually on the planet are using Facebook, Twitter, and different types of social media. And people use for different reasons. But Obama, or the President Obama, he actually used Facebook and social media to do the campaigns of his election, 2012 election. And he not only just that he did the campaign, but through the social media he gathered actually huge pool of volunteers from across the US who were able to help them in the campaign. So that was actually a very good success story that Obama had to share. Now, the third one that you probably see is that I'm sure most people are aware of this TV show that that was actually very popular in India, and that was Satyameva Jayate. So while this TV show was broadcast and people were telecast, and when the people were watching that, they were actually sending a lot of SMS, and through social media they were sending a lot of feedbacks to these guys, and they were actually analyzing that and dividing the population into different areas where they could actually send targeted messages, and also help actually to do the political campaign to deal with those problems. So that's a very good use case of analyzing the large volume of data that the TV company was receiving. So with these very interesting use cases, I'll try to actually explain what big data is about. So we understand that big data help in many companies, and not just the companies for profit, but also non-profit organizations, political parties, social events. So several things actually these days are using big data. So let's try to understand what big data is actually. So I'm not a very good fan of definition, so I will break this definition into pieces, and then we will try to understand. So as you see on the slide, that it's a large collection or large volume of data. Big data means big data, means large volume. And if you look at that definition that I have on the slide, that big data actually are both structured and unstructured. So that's very important characteristics of big data, that it is both structured and unstructured. One very other important characteristic is that the big data today may be small, but it grows so fast that it becomes big data in no time. So it has actually a fast growing property. And traditionally most data today are in the traditional RDBMS, and when the data grows really fast, it becomes very challenging for RDBMS to manage that fast growing data. And hence, when RDBMS cannot manage the data or has limitations when it comes to managing and storing and processing the data, then conventional statistical tools also fail. And we will see some of these features and where and why they fail or how they fail. We will try to understand that. So again, if I summarize that, big data has three very specific characteristics. And looks like the slide is a little bit distorted here on the screen, but let's see. So big data has three characteristics: volume, velocity, and variety. And volume actually means that large volume, like in terms of bytes, it's really large. And large could be where is probably or in terms of terabytes and zettabytes. Velocity, as I mentioned before, that velocity actually means that the data is growing really fast. So when the data grows fast, as you know that it poses challenges in terms of storage and in terms of processing. What makes it very difficult is the variety, that big data means both structured and unstructured data. And handling structured data, most people know how to handle that. But when it comes to unstructured data, handling of unstructured data becomes very challenging. So when it comes to big data, and when we put these three characteristics together, it becomes very difficult for any system to manage and make use of that. So we understand the big data from the characteristics point of view. Let's try to understand how big data is different from traditional data, and that will give us a good perspective what we are talking about. So traditionally, when we talk about data, their volume actually limits to somewhere in gigabytes and terabytes. But when it comes to big data, they are in terms of petabytes and zettabytes and even more. So big data is really much more bigger in size than the traditional data. And when it comes to handling the traditional data, when you want to use and store it, they are typically stored very centralized in RDBMS. So traditional data are stored centrally. However, big data, you cannot store the data centrally because it's very large. It will not fit in one computer or in hardware. So it's typically the way it is managed. In the sense, it is collected, stored, and made use is in a distributed fashion. So big data is very distributed. When it comes to structure, traditional data are very structured. They are in tables. They are very fixed. They have very fixed structure. However, big data are either unstructured or semi-structured. So I'll give you an example. So big data is structured data. We understand that it's in the form of tables. You have columns and rows and all that. But when it comes to unstructured data, it doesn't have any specific format, such as emails, such as textual content in emails, such as videos, audios. These are unstructured data. Now, when we manage the traditional data and when we put them in traditional RDBMS system, we have to adhere to very strict schema. That means its data model has a very strict schema. However, in case of big data, because the data comes from multiple sources, multiple formats, and there's no really such thing that will allow you to have a very good schema. So in this case, it's a very flat. And most people are very familiar with traditional RDBMS system, and we all know that there's a complex relationship when you have data in tables, that primary keys, foreign keys, multiple tables linked and all that. So that is how traditional table data are organized. However, in case of big data, since it's flat, there's no relationship. So that's how actually it is stored. At one place, when the big data does not have any relationship, it makes it very flexible. At the same time, it becomes very challenging when you want to use it. So let's try to understand how. So these are some of the facts, and these are not the only facts about big data that actually make big data look very interesting. So let's see. We create almost every day worldwide 2.5 quintillion bytes, which is 1 raised to the power 18. 90% of world's data were created in the last 2 years. That means all the data that was in the past was just 10%. Just in the past 2 years, people have started really producing a lot more data. And if you are producing 2.5 quintillion every day, then you can imagine how much data we will have produced in next year and year after. Now, 80% of world's data is unstructured. Now, this is a very interesting fact. You know that only 20% data is structured, and we know that majority of software or analytics applications that are built uses structured data because they are working off traditional RDBMS system. So they are using traditional structured data, and only 20% data are structured. That means all the intelligence that we are seeing around us are based on structured data. If we are able to make use of unstructured data, the systems that we will have or the analytics that we'll build will be much more intelligent and will be much more meaningful, because we'll be able to leverage the data, and the data is very, very powerful thing when it comes to analytics. So, these are some of the numbers, but let's understand how industry is generating the data. This will put us into perspective where those 2.5 quintillion data is coming from. So let's consider Walmart. And those who are familiar with Walmart, Walmart is actually a retail store. And I have to give an analogy to what we see in India, probably Reliance or probably Big Bazaar, they will actually be they're a very smaller size, but that's what Walmart is. They're retail stores chain all across the US and probably in different parts of the world. So Walmart actually produces every hour 2.5 petabytes of data every hour, and that's huge. And so Walmart is one company. There are several retailers like them. How much data they collectively create, that's something to think about. Facebook, pretty much everybody who uses computer uses Facebook. Then Facebook, and this data is about 6 months old, so they might have changed, that they are processing 500 terabytes of data every day. And 500 terabytes is a big number. This is another interesting thing, that YouTube, we see video on YouTube, and the YouTube published that roughly around 72 hours worth of video are uploaded to YouTube every minute, and that is actually again mind-boggling number. And 5 billion people use phones for various purposes, like making phone calls, of course, SMS, email, internet, social media, so many things they use, using cell phones. That is another source of, where the data is being generated. So what we see here is that what will be the size of the data next year and year after, and where those data come from. A few examples that are on the slide will give you some idea. So moving to the next one. So what we understood is, so the big data, and in order to understand big data analytics, we are now understand big data. Now let's try to understand analytics. And probably most people understand analytics. So let me put that a formal definition, or just a pictorial view of analytics. That when it comes to building the analytics, what we do, we take the data, we apply some statistical and mathematical algorithm, and build some model. That could be exploratory or it could be predictive models. Once we build a model, then that model, we pass the data through, and then that model gives us the information which will allow us to get insight. And once we get the insight, that insight should allow us to take some action. And that is what actually the entire life cycle of big data analytics is, or analytics in general is. So using the data, applying mathematical concepts or formula, building the predictive model or factual model, and then gaining insight. And once you gain the insight, you take some action. So the ultimate goal of analytics should be to gain actionable insight. So let's put them both together. That means what is big data and what is analytics. Of course, if we put them together, then we have big data analytics. So what is big data analytics? It is basically a process in which you collect the data, and collecting the data means what kind of data? Large volume of data from various sources, and we will see with the very quick example. Once you collect the data, of course you have to organize in certain fashion based on your business need, and then you do analysis. Once you do the analysis, why you do the analysis? To discover some patterns and some information that will allow you to act on. So that is how we put big data in perspective. That means you have large volume of data and you do the analytics of that data, and that is what big data analytics. Of course, very easy to understand that way. Let's try to get some idea how it differs from traditional analytics. Traditionally, the data are stored in RDBMS systems, and when the data is stored in RDBMS, before we do analytics, we first understand the data, and the data are so well structured that analysts understand the data very well. So in case of traditional data or traditional analytics, the data are well understood. However, when it comes to big data, big data is both structured and unstructured. That means unstructured data does not have any format and hence hard to understand. That means when you do big data analytics, you are actually doing the analytics of the data which is not very well understood. Huge difference from the traditional analytics. Now, since traditional analytics is built on top of relational data models, it's traditional data or traditional analytics has a lot of limitations, because those limitations come from the fact that the traditional RDBMS system has inherent limitations. When it comes to big data, it gets the data, or in case of big data, the data comes from various, or comes in various format, and from multiple disconnected systems, and they have almost no relationship, and that makes it even harder to build the analytics. So in case of traditional analytics, you are working with data which has very well understood and well formed relationship. In case of big data analytics, you work with data which has no relationship, and it is very hard to understand because it has no specific structure and format. So that actually gives us some idea about the challenges, but there are some technical challenges, and those technical challenges are that first, RDBMS has limitation, and when it comes to handling big data, RDBMS clearly fails. And if you have large volume of data, let's say you are using some statistical tool, and if that tool takes the entire data, loads in it, and then work through the data to build the analytics. One example would be SAS or SPSS or any analytical tool. They actually load the data first and work through that, do the computation, and give you the analytics. Now, if you load the data in one single computer, and that computer memory is limited, that means you can load only so much data, which has to be less than the actual RAM or memory of your system. So when it comes to large volume of data, which you will not be able to load in one single computer, traditional analytics fail. That means we have to actually, or traditional analytics software and system fails. So first thing, loading the data into the memory is a problem, because you need a really, really large memory, and those companies who use large volume of data and use traditional analytics tools such as SAS or R, they have terabytes of RAM, and the RAM is expensive, and the hardware they have is also very sophisticated enterprise hardware. So dealing with large volume of data is very expensive in traditional technology. So basically, even if you are able to load the data in some way or the other, processing them becomes a challenge, because you have very limited processing power, and it takes time. So these are some of the challenges, and again, very important thing, that traditional RDBMS system, if you want to scale, scaling of traditional RDBMS is very, very expensive. So basically, when it comes to handling, managing, processing the big data, you have several challenges. How to overcome those challenges? There are tools and technology that we will talk about very shortly. That there are several technology out there in the marketplace that we'll use to actually do the big data analytics, and we'll learn that in this webinar. So the next slide that I have is basically I wanted to give you actually a very quick idea about different types of analytics. Typically, you can categorize analytics into 4 categories. Of course, different people have different way of categorizing it, but this is how I would categorize it. Descriptive. That means you want to know what exactly happened. People also call this as a fact analytics. In case of fact analytics, you have data, and from the data, you say what has already happened. I'll give you an example, and I'll use that example in all 4 types. So let's say you have a student's record in a university, and based on that record, you want to just understand how many students failed last semester, how many students passed the exam with 60% or above his score. Now let's just take these 2 facts. These are actual facts. That means these already happened. Second category is diagnostic analytics. In diagnostic analytics, you want to understand why something has happened. In our previous example, where we took the example of a student failing, if you want to understand why the student failed, one fact could be, or one reason for a student to fail might be that the student did not have enough background, or it did not meet the prerequisite. So that could be one diagnostic analytics. Third thing that you have is predictive analytics. In this case, what you do is that you do a prediction, and you say what will happen in the future, or what is likely to happen in the future. Example, based on the historical information, if you are able to predict how many of your students in the university, or how many students in the university will fail the exam next semester. If you are able to do that, that is called predictive analytics. And we'll talk about all these shortly. There's another type of analytics called prescriptive analytics, that what should I do about it? That means you are taking some action. Now, if you look at the graph at the bottom, where it is kind of plotted against complexity. So basically, what it says is that for different types of analytics, you need different levels of skill, and the level of skill that you need, and then the different types of analytics, how they impact the organization. So if you look at the what happened type of thing, that means it's a very quick go and fetch the information from your data, pull the data, and then present it. That's basically a very factual thing. So this is basically, if you talk about RDBMS, you are just doing some sort of select and do some computation on it, and then you bring a fact and saying that this is what happened. So the skill level is also very, you don't need a very high skilled people for that. If you do the what happened thing, you need a little bit more sophisticated skill, and if you do the predictive one, you need really much more sophisticated skill. But when you do something like prescriptive analytics, that you suggest something, you do some recommendation for action, that requires a lot more sophisticated skill. Each and everything has some impact on the organization. Each type of analytics has some impact on the organization, and if you do the prescriptive analytics, the impact on the organization is, in terms of business, is largest. Let's go to the next one. How do we actually do the analytics development? And probably from here onwards, it will become a little bit technical. So first thing, identify the data source. And in case of big data, data sources could be many. Once you identify the data source, you have to select the tools to do three things: collect, store, and aggregate the data. So first you have to get the data somewhere. Understand the business domain, because analytics is not something that you can do without knowing the business domain. If you are doing the analytics of banking, you have to know the banking domain very well. If you're doing the analytics for healthcare, you have to understand healthcare very well. So doing the analytics really requires you to understand the business domain. Once you have that, then you identify the tools and technology that will allow you to process the data in order to give you the information for your analytics. Then you build a mathematical model and then visualize the data. Once you have the analytics ready, you visualize the facing thing. Validate your result. This is very, very key. Once you build the analytics, you have to validate. Let's say you predict that 20 students will fail the class. Then you have to validate. And in order to validate, you have to actually rely on the historical information, build the algorithm, and then validate with the historical information and then move on. Validate the result in real time, and then based on that you do some learning, and then that learning you again re-implement to actually build the model much better than what you already had, and that is where machine learning will be very useful. So basically learn, adapt, and rebuild your analytical model. So again, this is not a machine learning class, but I just wanted to give you an information that building actually model to do the analytics is very important. And how you will build a model, that's where machine learning will come into the picture. So if you give a formal definition that, if you are doing machine learning, what is machine learning? So basically, let's say you have some experience of winning the chess. You play the chess, let's say you play the chess first time against some second person. Once you play the chess the very first time, very likely that you will lose. If you play the chess 10 times, likelihood of you winning will increase. If you play the chess, let's say 50 times, 1,000 times, the more you play, your likelihood of winning will increase. And at some point in time, you will become perfect. So that is what actually machine does too. You give some sort of input and you get an output. Take that output. When more data comes in, you provide that input, compare with the output, correct your model, and then keep doing this over and over. The machine will learn and give you better and better analytics. So let's put that into a little bit perspective. So there are two types of machine learning, supervised and unsupervised. In order to do the analytics, you have to build a model. And that model will come from one of these two techniques, supervised and unsupervised. In supervised learning, what you have is that you have past data. That means you have a training set. And using that training set, you actually build a mathematical model. Any new data that comes in, you pass through the model, and that will give you a prediction. So basically, there are two types of supervised learning. One is called regression, and the second one is classification. Regression is that you predict a single value, such as, let's take an example of our previous, let's consider our previous example, where a student failing or passing the class. So if you say that a particular student will get, let's say, 60% marks in the exam, that means that student, you are predicting a very precise single value, and that is called regression. If you predict something like XYZ will fail or a student will fail the exam, or a student will pass the exam, or a student will be at the boundary line of the exam, boundary line, right? If you do something like this, what you're doing, that you're classifying the entire, population of the student into, let's say, three different categories. That pass class, a class who will pass, a class who will fail, a class who will be at the boundary line. So this is classification. That means you predict a class of values. We'll try to see what it looks like. Unsupervised learning is that you are given the data, you have no clue how the data are related, and then you will try to make some sense out of it. And the technique to do is called clustering. We'll see with some examples how these things work. So in case of, so this is actually model development slide where I talked about 3 different models for linear regression, logistic regression, and clustering. In case of linear regression, as actually, unfortunately, for some reason, when I published the presentation, it got changed. But here, actually, in case of linear regression, H equals M0 plus M1x1 plus M2x2 plus M3x3. Let's read it that way. So basically what you do is that you build actually a formula which is linear, and we'll see what that means. In case of logistic regression, you actually predict either 0 or 1, and that means you predict binary thing or a particular set of class, and we'll see what that means. So and clustering is done by a technique called k-means, and k-means is basically it provides an algorithm to actually generate cluster among your data. And let's take a look at all these 3 in a little bit better way. So this is actually a example of linear regression where you have, let's say, a relationship between GPA and GRE. GPA grade point average and GRE is graduate record exam score. And let's say you have GRE and GPA score, and you want to know how GPA is related or how GRE is related to GPA. So you plot that. Actually, let's say a student who has a GPA, let's say 3.2, and he got a GRE score of, let's say, 600. Plot all the students, the data that you have in a scattered graph like this. Once you have the graph, what you do is that you actually plot and you pass or you draw a line like this. That line should pass most of your data. Now, in this particular example, again, it's the whole idea of this is that you build actually a linear model. And the way you build a linear model, that you draw a line that passes through most of your data. And once you do that, then in order to predict, let's say I want to predict that somebody who has a GPA 3.5, what will be his GRE score? In that case, what we do is that we draw this line very clearly, and you see that at 3.5, the GRE score is coming somewhere around 680 or so. So this is how you do the linear regression. Now the question is, and actually the important thing to know is that how to plot this line. The line which touches the maximum point. How would you do that? Can you do it manually, or is there any formula? So that is what we actually do in machine learning, that we actually come up with a formula that tells us what this line looks like. That means what will be the slope of this line and what will be the intersect of this line. And probably most people know this formula, y equals mx plus c, which is the equation of a line. In case of logistic regression, again considering the same data, let's say we want to understand that based on the GRE score, who will get admitted in a college and who will not. So based on that, what you do is that you plot the score, rather you plot the you plot the existing data. That means you have the data that how many students got admitted, what was the GRE score, who did not get admitted, what was the GRE score. If you have the data, you plot it. Once you plot it, and then you actually want to predict that somebody who has a score, let's say 580, whether he will get admitted or not. So you see clearly in this graph that that student will get admitted. Now again, this is not true if you have very small data set, but when you have large data set, there is an algorithm in machine learning that will allow you to actually build a model and build a formula that will allow you to do this kind of prediction. And with a small data set, the prediction is hardly accurate. When it comes to large data, when you have large data set, the prediction basically becomes accurate or close to accurate. Clustering is just identifying the pattern. Let's say you have actually, let's say you have collected the data on height and weight of people, and you plot this. And based on that plot, you build a cluster that is shown here with blue, green, and red colors. So these clusters probably tell us that people who, so this is actually trying to find the pattern of height and weight. And if you plot this cluster, this will actually become very useful. Let's say somebody is trying to market, then people who belong to, let's say, this blue cluster, probably they will be good candidate for marketing some, let's say, nutritional content or nutritional, or let's say product. Those people who are in the green cluster, they are people probably are very good when you try to market them fashion and clothing, because their height and weight ratio really looks good. Now, those people who are in the red cluster probably might be a good candidate for marketing, let's say, gym related product or health product, something like that. So you see, identify the pattern in the cluster and make some meaningful insight, and then you actually basically take some action to drive some business. So let's get to the very important subject, that what are the analytical tools that are out there in the marketplace, and what kind of tools we will use to build analytics. And these are some of the most famous tools out there in the marketplace. I may be missing a lot. It's not easy to put everything on the slide, but just to give you the most common ones: IBM SPSS, SAS, Stata, or MATLAB. R is the only one which is open source. Everything else are commercial, and you have very expensive license. But it's important to know, R and MATLAB have the maximum or most comprehensive support of statistical functions. And I use R very intensively. My company uses R, and I have known that I know that majority of big corporations such as Google, Yahoo, and all these guys, they use R, and of course MATLAB as well. But R is the most popular among modern companies such as Yahoo, LinkedIn, and all these guys. So those were traditional analytics tool, and those traditional analytics tool actually fail when it comes to dealing with large volume of data. So what is the technology stack that you should use in order to do the big data analytics? And to do that, as you see in the middle, you have Hadoop. Hadoop is a basically a big data platform in which you can process large volume of data cheaper and faster. And Hadoop allows you to do the analytics really fast on commodity hardware, and it can grow and scale really big. So this is one of the most famous and most popular big data analytics platform that are being used all over the world. There are several other technologies that were built around Hadoop, and they are like Pig for processing large volume of data and using Hadoop. Hive is a data warehousing tool, and Pig was built by Yahoo, Hive was built by Facebook, and Hive provides SQL type of infrastructure. So you use SQL command to do the query and all that in Hive infrastructure. HBase is actually Hadoop database. It is large volume data that you can store in HBase without actually compromising the performance. Where traditional RDBMS fails, HBase actually provides a very super quality, high quality actually, large scale, large volume data storage. Zookeeper and HBase has to work together. Zookeeper actually provides metadata information for HBase. Avro is actually a serialization framework that the large volume of data is structured, unstructured, whatever you have, you can actually serialize using Avro. R Hadoop is another tool. So I mentioned about R. R has a lot of mathematical and analytical or statistical formula built in. R provides basically, R is a programming language to do the analytics on traditional data. When it comes to building large volume or big data analytics, R Hadoop is one of the most popular tools out there in the marketplace. Scoop is actually a tool that allows you to export data, or rather import the data from traditional RDBMS to HDFS and back from HDFS to RDBMS. So Scoop is a very, very important tool. Flume is a tool or technology that allows you to aggregate logs generated across multiple computers in the cluster. Uzi is a flow orchestration engine, or rather a flow orchestration mechanism to actually, or rather an engine to allow you to process your data in a flow and control the flow. That means, if let's say you are processing a text file, you go through a certain flow that you simply grab the content of the text file and then do something. Let's say you have a PDF file that you want to process, then probably what you will have to do is that you will have to actually convert that PDF in, PDF is a binary, so you have to read the PDF, you have to parse it, and then you will actually get the data. Let's say you have XML file, the processing, processing steps of XML will differ. Let's say you have a Word document, processing will differ. Let's say you have images, the flow of processing will differ. So you see that the different types of documents, Uzi will allow you to actually configure the process and then manage that, and then you do the processing on top of it. So it's a flow orchestration mechanism. Now, these are not the only tools and technology built around Hadoop. There are several out there, but these are some of the most famous ones. Let's get actually, it's already time up, but I will actually quickly go through, some very practical things which are really important here. So you see that this is actually the high-scale computing platform that we are currently using in our company Accure. That we have different actually analytics applications that are running, and this is a real platform. And of course, you can look at the system and then you can understand. I will not spend much time. And we are using pretty much most of the big data analytics tools, but this is the architecture that actually gives you a very good information. There are several industries where Hadoop and big data has been used, but let's try to see what we have done. So this is actually a real system. We call it Accure distribution of Hadoop, and this is actually a big data analytics platform. And what this platform allows is that, this is actually a solution that we did for banks. And you see for on the left hand side, IT optimization and cost saving. So actually moving from just, expensive hardware on top of Hadoop itself is a very good cost saving. We have built actually mathematical formula, and we have an algorithm. And now we can actually, and of course it is built based on big data, that we have actually a fraud detection and risk management module. Based on various social media marketing and campaign analysis, we can actually predict, let's say the bank is advertising for term deposit. Based on the campaigns and based on the social media analytics, we can actually predict who is going to buy the term deposit, and which is very powerful. Sentiment analysis, like how people are perceiving this bank by mining this social media and then understanding how the people are actually talking about the bank, what they're talking, how they're talking, who they're talking to. All these things actually we analyze and of course they are purely unstructured data. We do basically sentiment analysis. Large-scale branch reporting, again, this is very traditional, reporting type of thing. I will not spend time. Churn analysis based on their existing source of data, customer interactions, social media. We actually are able to predict who among your customers are going to move away from you and go to your competitor, so that before it happens, you take some action. We have 360 degrees. So this actually 360-degree view of customer relation that actually allows you to actually understand your customer from all different perspectives. So in order to do that, what we do. So here is actually another slide that actually tells you that from many systems that you have, many data sources, CRM, bank data, customer data, social media, RDBMS, cell phones, from various sources, you aggregate the data, collect the data, build the analytics, and then you understand your customer. So that is how you can get the 360-degree view of your customer. There are several other applications. Actually, this is one application that we as a company built called Einstein, but why I put it here, that it is actually very good information, that it answers 3 different questions, very important questions. This is actually a school product being used by an engineering college. They understand and they can actually predict who is going to fail the next semester, so that they can intervene and coach them, and they can actually bring those students up to the level. So you do it before it happens, so that you can take action and improve. And it actually tells 3 things: who is going to fail, who are going to have attendance shortage, and who among the students have gone off track. So those 3 important questions it can answer. And of course, this is built based on big data. We have another application called diabetes and cardiac disease prediction based on the lifestyle data. Of course, we have to do a lot of data crunching, but based on lifestyle disease, it can predict these 5 diseases: diabetes prediction, cardiovascular disease prediction, coronary heart disease, hypertension, and stroke. They are lifestyle disease. So based on some lab data like cholesterol level, glucose level, all those information, we can actually predict who is going to have diabetes. So you see in the slide that it tells us that John Doe has 45% probability of developing diabetes in 8 years. And based on that, if you want to bring that prediction down, it actually gives you the recommendation that lower your weight by 3 kg, lower your fasting glucose by 15 in 3 months. So that actually is a very good analytics that anybody can use. Of course, doctor can use to communicate to the patient or any individual like you and I can use, download on a phone. Currently it's based on Android. You can download it, understand your own health profile, and actually stay healthy. We have social media analytics to understand how the people are. So this is very important thing that let's say there is a retail company and or a product manufacturer. The product is out there. People talk about that product. Let's say it's a shampoo. Everybody, a lot of people talk about that shampoo in the social media, Facebook, Twitter, a lot of places. You collect the data and then understand whether this shampoo is really gaining popularity, whether the people think positive or negative about the shampoo. You can compare against the competitors, how the people are perceiving that. Now, that is again built based on unstructured data with a large volume of data mined from different social media. So those were some of the things that I wanted to cover. So if I want to conclude this with the slide, that big data analytics is complex subject. You have seen that there are so many tools and technology out there, so many different ways of doing it. It's a really complex subject. What is important is that you need to know the business domain and you need to have a mathematics background in order to build the big data analytics. Then there are a large number of tools and technology. What is important is that what tool you select, what technology you select so that you get good success on the project is really crucial. So with that, I would actually open this for discussion. And if you have any question, please go ahead and ask. Because of that, some technical issue, we got delayed. So, and also this topic is also very wide, so it took a little bit longer than I anticipated. I opened everybody's mic, so feel free to ask question. Or if you want to type, go ahead, type and ask your question. I think I prefer that everybody type it because there is a lot of background noise. So why don't you go ahead and type your question, please. So one question is that suggestion for training institute for big data analytics. Actually, WizIQ, there is on WizIQ, that is online training institute, and there is already a course available on big data analytics. So you can check that out. And there is another company called Hadoop Career that is based out in Bangalore. But I would really recommend that WizIQ courses. The content and everything is really good. Plus, you could actually, do it remotely at your own. And somebody actually posted the link for WizIQ course. Other question that I have: will you be sharing a copy of the presentation? I think the presentation is available for download from WizIQ website. So question is, how about job opportunity? So let me actually start with this. Very recently, Harvard Business Review, HBR, published on there was actually big bold title on their cover page that the sexiest job of 21st century is big data science. That actually triggered a lot of opportunity, because you see that first thing is that big data is very rare skill, the tools and technology that people use. Analytics is another rare skill, and if you combine both of them, it's really very rare skill in the marketplace. Now let's consider the companies. Today, every company is having some sort of data, and everybody is trying to figure out what to do with the data. And according to this company called what is that marketing research company I'm trying to select? Gartner. So Gartner actually predicted that by 2015, 2/3 of analytics software will have to switch to big data, basically platforms such as Hadoop. So basically, you see that how many companies are actually going to hire in order to do that migration. Very recently, there was a report sent out by Hortonworks that big data market actually grew from 2012 to 13 by 200,000%. So you see that the market has grown really big. According to another report that I collect, that roughly around $2 billion was spent or invested in big data analytics startups in 2012. And a lot of those startups are really gaining popularity these days. So with that, you see that market is really demanding, but the skill is very short in supply. I did actually a quick search on Naukri.com on big data analytics, and I found roughly around 300 companies are hiring for big data engineers in India, and thousands of companies are hiring in the US. So there's really huge demand in the marketplace for big data, analytics guys. Now, next question that I have is, what are the mathematical skills that are needed to focus on for successful big data career? Very good question. The mathematics that you need, or the skill that you need, of course, the stronger you are in math, better it is. But linear algebra, that is one thing. Second thing is statistics, probability. And you need to be very good in linear algebra, such as matrix calculations and all that. And a little bit of calculus definitely helps. So those are some of the really very important mathematical concept I can think of. So in summary, linear algebra, calculus, statistics, probability. Hope I was able to answer the questions. So I'll take one more question. That will be one last question. So of course, today the companies are really moving towards analytics, and there will be a large number of analytics projects coming out, and people will be working on it. So the question that I have is that you have 11 years of experience in different domain, telecom, project management. Switching to big data will be a practical thing or not? To give you the answer, actually, I was providing the training to one of actually, I would say, Fortune 100 companies and multinational companies. It's a UK-based telecom companies, and one of their very senior manager was part of that training. He was attending the training, and a few months later, he actually called me and mentioned to me that by going through the training on big data analytics, he is now able to manage the team better, and he is now able to actually contribute to the discussion that goes in, and he is now he understands the technology, so he can review the architecture, review the plan and everything more effectively than he was ever able. So that was one thing from the management perspective. So learning this technology is very, very important in order to be successful in doing the project management of project based on big data analytics. Now, switching to a career, of course, this is a brand new area. Most people do not have actually analytics experience, and there is a shortage of demand, shortage of a skill in the marketplace. When that kind of things happen, picking up from at this level will not be a bad choice, because anyway you have to start from somewhere, and the industry has to actually hire people. So getting into a career in big data at this point, I think is very feasible, because there are a lot of people, skill is rare, so a lot of compromise hiring might happen. All right, so I think those are some of the questions that and it's also we are 18 minutes past the time, and since we lost some time, so I gave a little bit more time. All right, again, I would like to conclude this with very big thanks to everybody who sacrificed their evening time after the hour. Thank you very much, and hope you were able to learn something, and hope you will actually make a career choice if that interests you. Thanks to all, and thanks to the coordinator, and thanks to WizIQ for this platform. So great. Everybody has a very good night, and those who are attending this webinar from outside India, and if there's daytime, I really wish you all have a good day. Thanks all. Bye-bye.